Today we're going to go through self-inductance and mutual inductance in Chapter 5. These are the final answers for today's questions. Questions 1. The inductance of the coil is 3 millihenry. The current flows through the coil changes from 0.26 to 1.3 ampere in 0.18 seconds. Calculate the magnitude of the average induced EMF in the coil within the periods given. To determine the magnitude of the induced EMF, since you are given the inductance of the coil, therefore you just apply the equation for self-inductance. So EMF is equals to negative L di over dt. Substitute the values into the equations and you will get 1.7 times 10 to the power of negative 2. Now you have to be careful with di. Di is a final current minus initial current. So in this case, we use 1.3 to 2.6. Therefore, your final answer is a positive value. Questions 2. A flat coil of wire has 500 turns. The magnetic flux linkage for each turn is 0.055 Weber. When the current in the coil is 3.5 ampere, calculate A, the self-inductance of the coil, B, the energy stored in the coil when the current is 3.5 ampere. To calculate the self-inductance, let us apply the equation for self-inductance again. But this time, we are not going to use EMF equals to negative L di over dt. In these questions, according to the information given, I'm going to apply L equals to N phi over I. Substitute the values into the equations. L is equals to 7.86 Henry. Now, some of you might ask, isn't 0.055 is a magnetic flux linkage? If you read the questions carefully, that is the magnetic flux linkage for one turn. Because questions mention the magnetic flux linkage in each turn, so it's just for one coil. Therefore, when it comes to these questions, you still have to times with the numbers of coils in our questions. Questions B, calculate the energy stored. So apply the equations for energy stored in inductor. U equals to half Li squared. Substitute the values into the equations and you will obtain energy stored equals to 48.14 joules. Questions 3. Coil 1 has L1 equals to 30 millihenry and N1 equals to 150 turns. Coil 2 has L2 equals to 40 millihenry and N2 equals to 250 turns. The mutual inductance is 4 millihenry. At a particular instant, the current is 5 milliampere through coil 1, and this current changes at a rate of 4 ampere per second. Determine A, the flux linkage in coil 1, B, the flux linkage in coil 2, C, the induced EMF in coil 2. According to the information given, the current is flowing in coil 1. Therefore, in order to calculate the flux linkage in coil 1, we apply the equation for self-inductance. So self-inductance, the equations N phi is equals to Li1. Now, since the question is asking for flux linkage, therefore we substitute N phi with capital letter phi 1. So capital letter phi 1, the flux linkage in coil 1 is equals to Li1. Substitute the values into the equations and you will get flux linkage equals to 1.5 times 10 to the power of negative 4 Henry. Questions B. Now, you still want to calculate the flux linkage, but remember, there's no current flow in coil 2. Therefore, in order to solve this question, let's apply the equation for mutual inductance. Mutual inductance equations. N phi equals to Mi1. Now, you're still using I1 here because when it comes to mutual inductance, the current should be coming from the neighboring coil. So once again, since you are looking at flux linkage, therefore replace N phi with capital letter phi, but with a subscript 2, because now you want to calculate the flux linkage in coil 2. So magnetic flux linkage 2, I1. Substitute the values into the equations, you will then obtain magnetic flux linkage equals to 2 times 10 to the power of negative 5 Henry. Question C. The induced EMF in coil 2. So once again, let's apply the equation for a mutual inductance. But now the equations that we are going to use is induced EMF 2 equals to negative M di1 over dt. So again, since you are looking at mutual inductance, therefore you use EMF 2, but the current is coming from the neighboring coil, which is I1. So substitute the values into the equations, and you will get EMF 2 equals to negative 1.6 times 10 to the power of negative 2 volt. That's all for today. I will see you all again tomorrow.